So here a variable electric field is produced. So I want that expression for magnetic field. I just know I brought it only some proposal. Now I want exactly the magnitude of electric field here. So shall I say that this having a radius 2r or 2a will take it. The diameter of this r equal to a. Okay, let's do one thing. So shall we take a circle now? Okay, let's try to see that where all this magnetic will be present. Okay, let's take the Ampere circuit law. So what is this? This radius is equal to now. So shall we put E bar? E bar, what is the direction of E bar? This will be plus Q minus Q. The direction of E bar will be. How is E bar? If I stand here, how E bar will appear for me into the plane? So I'm going to circle them. Okay, I want the expression for the magnetic field inside as well as outside. So first, able to understand. I think I can't give 3D diagram anything. Please do understand. So this is E. So I want expression for this one. What about the field inside at a distance r? Okay, let me draw the Amperian loop. So according to the, so what is the current density formula? ID should be equal to. How to bring expression for that magnetic field. Now I'm interested in expression for the magnetic field. So from where to bring that expression for magnetic field? Shall we take help of same Ampere circuit law? But there's no current carrying element, no? So who is current carrying element here, no? Who is current carrying element? So let me take, this is dl. So integral of dl equal to mu naught into I net, or select a net current enclosed here. So no question of conduction current. So what all it should be displacement current on. So what is the displacement current is equal to? So this should be equal to only ID, I'll write it. So this is the field strength at point P. Okay, we'll do one thing. IC plus ID. This should be 0 into ID. So mu naught ID. So this should be B into 2 pi R. What is ID? ID is the total current, no? So this ID shall be write epsilon naught into d phi E by dt. Displacement current formula. Don't write dq by dt. So let it be like this. So BP into this is 2 pi R. Now what about the radius? So the total electric flux for pi a square is this much. So what is the electric flux? What is the electric flux for a region of pi r square? We'll keep this much here. So now we wanted this pi, no? So I'll divide these two. So pi by pi e is equal to. So what is this phi? This should be equal to epsilon naught r square a square d phi e by dt. mu naught epsilon naught. Okay, one r will get cancelled. So we'll simplify this one. So this should be equal to how much? Mu naught epsilon naught r by 2 pi a square. So this should be, what is the electric flux? I think d phi e by dt, again, what you can write. Okay, let's come for this one. How you define electric flux here? E into area electric flux, E into area. E is what? Q by A epsilon naught into A. A get cancelled, so Q by epsilon naught will come into Q by F naught will come. So this d phi E by dt, what shall I replace here? No, Ampere circuit law I'm applying in different way. That's all. Don't get scared anything. We are not doing anything very big. So d phi E by dt should be equal to 1 by epsilon naught dq by dt. So this epsilon naught get cancelled. So mu naught r by 2 pi a square dq by dt. And this is what? Equal to conduction current. And what is the conduction current? You know that. Go back to RC circuit. Go back to RC circuit. So like this, what happened? We'll get expression for this one. Look at this field. Is it a uniform or non-uniform? The field produced here, will it be uniform or non-uniform? Will be non-uniform. What should be the direction of that? The direction of that should be in the direction, like a, go back to Ampere circuit law. How do we predict the direction? So how the displacement current should be into the plane. So therefore here the B bar I'm going to show like this. Is it okay? So everywhere you draw the tangent. If E bar into the plane, B bar will, and how these two fields will be perpendicular to each other. And as you, and what is the field at point O? Exactly the axis of this two disks will be 0. And as you start moving, it increases. Okay, agree this? And where it will be maximum? At small r equal to A. It will be maximum here. Okay, let me put all the things. So some points will keep it here. 1, 2, 3 like that. So that will be easy for you. So exactly on the axis, then 2, 3, 4, 5. Okay, what about the field at 1? Will be 0. Any reason? R is 0. Field at 2 and 3. Field at 2. Mu naught R by 2 pi A square IC. What is IC, sir? IC, I don't know. IC is what? Like how you write? Charging of capacitor. Okay, there's a discharging current here. No? V naught by R e to power of minus TRC. Charge, okay, current it is discharging current. So that, and look at the B bar, is it a constant? No, it's variable. It varies with the time, and also at different points will be different. So field at 2 will be this much. Then what about field at 3? Mu naught R equal to A, no? R less than A. This is R equal to 0. So this will be mu naught I C. What about field at 0.4? How to calculate here? Total current enclosed will be only quote ID, no need to calculate anything. No need to calculate. What is the total current enclosed between the plates of capacitor will become equal to displacement current. So what about the field at 0.4? The 0.4 I'm going to derive it. B4 dot dl equal to mu naught into net displacement. And we already know displacement current is equal to conduction current. This will be 2 pi r mu naught IC. Ampere's circuit law, you apply that. Okay, this is about the field. Okay, look at this now. So what is the field at 0.4 or 5? For R greater than A. This is also equal to B4 equal to B5. Because both they lie outside, no? So now, what is our conclusion? What is the conclusion? RC circuit, what we studied is now totally different way I brought it, no? Sir, what is this? You did cheating. No, at that time, the necessity was that much only. So therefore, I just went only for that particular discussion. So here, as you switch on the circuit, the current flows here. Okay, clear this one. Now here, displacement current will flow. Due to varying charge here, electric field will be variable. This variable electric field will produce magnetic field. Can we calculate that magnetic field? Or is only theoretical way we can assume? No, we have a formula here. That's what this concept is. We do have a systematic formula. On the axis here, 0. And as you move away, it increases. Here, exactly at this point will be maximum. And outside again start decreasing. So where that magnetic field, variable magnetic field is produced everywhere here. So this is like a finite rod, no? Here. Means, sir, what about field here? Yes, it produces here also. This is like a finite rod, finite current carrying rod. Agree? So finite carrying rod, where did it produce field? Everywhere surrounding it. I'm more interested in these regions. So if you, for your confirmation, if you want here also, yes, you can find it. B6. Okay, somewhere here, B7, field will be non-zero. Of course, finding there again, you have to go for the finite current carrying wire formula. Now, sir, is it really a displacement current? Is that no? The varying electric field only, we are giving it a name. A current density is what should be there, no, to produce magnetic field. That's why we are just saying displacement current. There's no any wire. Don't think that again, sir, here iron wire. So here maybe sir copper wire between the plates, nothing. Nobody is there. So go there, you know. So how to calculate the displacement current, all the things. So what is the conclusion now? A variable electric field will produce magnetic field. So now the Maxwell solvent to propose its electromagnetic wave propagation, he needed this concept. He only modified that Ampere circuit law. He only modified the basic Ampere circuit law. Okay, clear now? So now what he said is like, to express its wave propagation, he has brought 4 equations called as the Maxwell's equation. Now, you meanwhile see it, I'll have a water. I tried my level best because if you see in the books, no, so more about the theoretical, you find very difficult. That's why I just took help of this way of RC circuit. This you find very difficult to analyze on your own. Okay, now Maxwell, after modifying Ampere circuit law, he just grandly proposed the 4 laws that they are called as Maxwell's equation. With the help of that, he said that electromagnetic waves, they propagate. Electromagnetic